Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Hi, and thank you so much for coming to this call today and talking with me. Just to sort of start off, do you mind introducing yourself as well as walking us through your journey to get you where you are today?
Sure. Yeah, so I am Mason Porter. I'm a professor of mathematics at UCLA. I also have a secondary appointment in sociology, and I'm an external faculty member of Santa Fe Institute. In terms of my path, I did my undergraduate education in applied math at Caltech. Then I did a PhD in applied math at Cornell. Um, and these are both separate programs from math programs. And then I did some postdocs. So a postdoc in Georgia Tech, primarily in math, but with some physics affiliation as well. A postdoc at Caltech in physics. And then in the fall of 2007, I joined University of Oxford as faculty member in the mathematics department. And then in 2016, I moved to UCLA to my current position.
I was just wondering what got you interested in math in the first place, and I think you also mentioned that you work in sociology and also studied physics at one point. So I was also wondering like the inspiration behind like studying or learning about those subjects as well.
Yeah, sure. In terms of becoming a mathematician, so I was interested in things like patterns and the various kind of really nice, very fanciful pictures that one could make. And I learned in high school about fractals. I mean, learned was like from somebody's report and in a class, right? Not part of the curriculum. And I saw the types of visuals it could make, and that was very inspiring. And in the process of trying to kind of find out about those when I was in college, I became more interested in the mathematics and applied mathematics itself, and went in that direction instead of going in like a computer graphics direction, which is what I had been thinking of. Um, and then in terms of becoming interested in other topics, I mean, I always liked a lot of the sciences anyway. It was not just that I only liked mathematics. And mathematics and physics have a very long and intertwined history and have influenced each other and complement each other. And when you're doing applied mathematics, a lot of that tradition has come from the physical sciences. And so a lot of my interest in things in physics came through that because these things are often very close together. So I guess you could say, so math is always a formal science, but it can also be a natural science, and I treat it as both in terms of what I do. The interest in sociology has a little bit of a different origin. I mean, it's maybe sensible to be interested in people just from being a person. I think that that's fairly common, but I was doing a lot of mathematics to study things like social networks and various processes that occur on networks. And so I was learning various bits and pieces of other topics in the process. Um, and I wanted to have more of an affiliation because I want to, when I use mathematics to contribute to a social system, to studying a social system, I want to do this in a way that is respectful to the domain experts, and just surrounding myself more often with domain experts was what I wanted to do to help to just help do that better.
Sounds good. I was also just curious about like sort of like based on your experience, what have been some like favorite areas of study or areas of research in terms of like mathematics and or your other interests?
Um, I mean, I have lots of favorites. Um, I guess I can bring up a couple things that are general and a couple that are specific. From the perspective of general, two subjects that fascinated me a lot, and this actually also kind of connects with the intersection between math and physics, are nonlinear science and statistical mechanics. So I know that those are buzzwords and, not necessarily ones that people would know, though they are Googleable, which helps at least. Nonlinear science is kind of the real name for what people sometimes call chaos theory. And the idea is that you can have systems that seem like they're simple when you write down the rules, but having this feature called nonlinearity, um, which essentially means that superposition is not holding. This allows very intricate behavior, even in systems that when you write them down, like write down the equations, look like they might be simple. And so the notion of complicated behavior coming from seemingly simple rules and including chaos was something that was very exciting to me. The other general one that I brought up is statistical mechanics. It's a little bit of a misnomer, I suppose. It's actually a subject very inherently at the intersection of math and physics. And the idea is that instead of just having things like, say, temperature that you measure, temperature is actually a derived quantity that comes from kind of vibrations of particles. And so statistical mechanics allows you to do sort of counting, and you start by counting particles and you derive macroscopic quantities traditionally like temperature, but ideas from statistical mechanics also play out in the study of, and this is another buzzword, complex systems, where now instead of having particles, the individual components might be humans that obey certain rules. And the collective type of features, these macroscopic features, instead of being something like temperature, might now be something like polarization, or might be a meme becoming popular or something. And so these tools from this area of math and physics get applied. Um, so then getting a little more specific on a couple things. I mean, I've been very excited about modeling how opinions change. Um, and so using that with equations and trying to see what can happen in idealized scenarios. I've also been very excited about, well, one particular very quirky project was a model for how cows synchronize their behavior, like how they might lie down at the same time or something. And so we were doing that looking at that in an abstract way, and that was a fun problem.
Sounds good. I was also just curious. Wait, I was also, yeah, sort of curious about since you take like such a interdisciplinary approach or like you have so many interests, I was wondering like how that sort of differs from like if you were just to like study mathematics.
Sure. I mean, so it's probably still more common for people to just take one road and just study math or just study whatever topic. That's actually not traditional. The notion of disciplines is not how scientists started out. Um, so I do this because it's interesting and I get to learn lots of stuff. But a lot of my colleagues, specialize more in areas of mathematics. And when they use the word application, they would even think of it as applying one area of math to another, which is just fine, but it's different from what I do. Um, I would say that I have sort of a broader scope because of that. Um, Arguably, this might mean that I go less in depth because somebody who studies the same thing all the time, is going to go into it very deeply, one would think. Um, but I like having this sort of breadth, and I think it's very interesting. I just, to me, I don't like to being pigeonholed. I don't like to say, okay, if I go only a little bit outside of my expertise, I'm suddenly lost. That's just, for me, that would not be so interesting. And I like being able to contribute to lots of things and to have interactions with people from lots of different scholarly backgrounds.
And then I think you mentioned before that you were a teacher or professor at UCLA. I was just wondering what were some of your favorite moments of like working with students or just like teaching in general?
Um, yeah, sure. I mean, I don't know if I have any individual favorite moments. I do love working with students. I mean, I especially enjoy mentoring in a more one-on-one type of context. So advising PhD students where you see somebody grow in their research from the beginning to when they get their PhD. And by the end, any reasonable PhD student, by the end, they're the ones teaching you, not the other way around. I mean, I'm sure they still have stuff to learn, but I like learning from them. And I love it when my students prove me wrong. You know, it's good. It's good when they prove me wrong. Um, and the more the more advanced they get in their education, the more often it's them proving me wrong. So again, that's good. But that's not any one favorite moment. That's more of a sort of tendency. But I love it when students succeed. If a student suddenly gets a job offer, or when we get the notice that a paper has been accepted, and when you get the paper, when you get a paper accepted, I've had a lot of papers, but this could be the student's first paper, and they're also the ones who were leading the paper, right? Like I was mentoring, but they were leading it. And so I like being able to be part of the story of them getting this good news, including ones that are, well, the paper acceptance is not life-changing, but it's still very exciting. But getting a job can be life-changing, right? And passing their PhD, and you get to be the first one to congratulate them when they successfully defend their PhD thesis. And so I love doing that. Again, I've done this many times. It's not one moment, but those are the types of things I really like.
Sounds good. And then sort of on that note, I was just wondering if you had any recommendations, pieces of advice, resources, honestly anything for high school students who are interested in pursuing mathematics in the future.
Right. So one of the things is that, nowadays, and this was not true when I was growing up, there's a lot of things available online, right? There's a lot of resources available online. Um, the quality can be variable, so that can be a little bit tricky. But like, there's a lot of very educational videos on YouTube, for instance, not just in math, but in various other topics as well. And that just was not there before, so you could take advantage of that. The other thing that's there are these online courses through these various organizations. I guess it's made less inroads than people may have thought, but they still exist and they're still resources. And again, the quality is variable, but this gives a chance to have some guidance in your learning, so you're not just reading stuff on your own. There are also other types of resources that are built towards a younger audience. Some of the organizations, some of the math organizations, one in particular has this as part of their focus, the Mathematical Association of America. They have some publications that I think are even high school student friendly. And they have a lot of publications that are college student friendly. And so those places can often be places to start to learn about things that you're not seeing in the curriculum. Another one I can bring up, I should have brought this one up first, but it just didn't occur to me. There's something called the Mathematical Contest in Modeling. And the main one, and this is to learn about mathematical modeling and applied mathematics. It's I think COMAP is the company that does this. The main one is university based, but they have a high school competition as well now. And so if you want to learn about applied mathematics, where you sort of start with some ambiguous problem and you try to turn it into a mathematical problem and then solve it. So like a word problem, but just ramped up really seriously. And so really an introduction to the type of research that people like me would do. I think that the high school mathematical contest and modeling, whatever the precise name of it is, would be a great resource for some students to try.
Okay, sounds good. And then sort of on that note, I was just curious, like from a professor perspective, what do you sort of do when your students are like struggling or like encountering a difficult problem?
Right. So this can depend a little bit on the level of class that you're teaching. And excuse me, the ones that I normally teach are either graduate courses or upper division math courses, which means that the people who I have in it, while it's not true that they don't struggle, they do have their struggles. They are people who are taking courses beyond the sort of core ones that might be more in line of what you're thinking of. So when students in my courses have trouble, I mean, for one thing, I want them to come to office hours, so that's what office hours are there for. So certainly students will oftentimes have questions on a specific problem. When they have more general questions, we can also talk about that further. But for the more advanced courses, there's probably fewer sort of broad-based resources available. For courses that are sort of core courses like calculus and so on, where you've got a lot of students, really a ton of students taking them, then there are some, getting a tutor could be helpful. There are some various resources that our department has. And so, although I have not taught those courses at UCLA, if I were teaching those and had a student struggling and were coming to office hours for me and the TA, was not enough, and working together on their homework if that's not enough, then I would encourage them to do those resources. But yeah, I've not been teaching the courses where those are mostly tied to.
Okay, sounds good. Thank you so much for once again coming to this call and sharing your experience. It was absolutely
Sure,
amazing. Thank you.
sure, absolutely. You're welcome. Thanks a lot.